Back to another video. This is Educational Codeforces Round 150, and we're gonna solve the second problem, that is keep it beautiful. It's a very interesting problem, and the problem is straight away implementation, but the implementation is very catchy. So let's see what the problem states. The problem states that you have an array, like a1, a2 up till ak, and they are defining an array to be beautiful. So when can you say an array is beautiful? That means if you can segment the array, like from the start, you take a set of elements from the array and push it to backside. So let's say you have like a b c d e f is the array. You can take any subarray from the start and then push it to the last. So it will be like abc can be pushed to this. Okay, so this is one condition, you have pushed it, but they want to make sure that the resulting array should be non-decreasing. What do you mean by non-descending is either the array can be equal or array can be equal and increasing. So if you are putting like df abc, d less than or equal to e less than or equal to f less than or equal to, similarly this condition should be satisfied. That is the rule of a, what do you call, it is the beautiful array. Okay, now in other words, they just told you some examples here. So suppose 1 2 3 4 5 is already beautiful because 1 less than 2 less than 3 less than 4 less than 5, it's already sorted, and they are telling that we can remove 0 elements from the array and append the 0 elements on the end. So 0 doesn't make sense here, but if it's already sorted, we don't have to do anything. And if it's like 3 7 7 9 2 3, what do? We can remove first 4 elements from the array. So if it is like 3 7 7 9 2 3, what do? We can take the first 4. Okay, what did they say? We can remove 4 first elements and insert them in the back in the same order. So let's take these 4 elements and put it here. Okay, 2 3 3 7 7 9 is sorted. That is, this is a beautiful array, but it's not like you have to push it here. Even this is also a beautiful array. They are just telling that hypothetically in some situation, the array, if you move from one, if you remove some segment from here to the backside, it should be beautiful. That's all. Now what is the question? That's the main part, right? You are given an array, you will be given q queries. Like let's assume that there are like a stream of numbers coming. Okay, like it's coming like this, like a plane, and you have to select these numbers in your array, like one by one number will come. If your resultant array can be made as beautiful with the incoming number, you mark it as 1. If it cannot be made as beautiful, you mark it as 0. Like you don't want that number. For example, let's say you have these numbers coming. Okay, 4 5 1 2 3. I don't know what are the numbers coming. First I see 4. So only one number is there, right? I can mark this as beautiful 1. Now next 4 has been processed. Now 5 comes. 5 comes, 4 is less than 5. Obviously it's beautiful. So in the answer I just append it as 1. Okay, and now 1 comes. Here something is catchy. 1 4 5, 1 is less than 5, right? 1 is less than 5, but can this be made as beautiful? Yes, 4 5 can be put here. So 1 is also one possibility, so I keep 1 here. Now 2 comes. If 2 comes here, again 4 5 can be pushed after 1 2, right? Possible. 3 comes, again 1 is possible. Now let's suppose a number like 100 comes. Can 100 be pushed? 1 to 300 is there, but something, any number from here can't be pushed to here, right? Or let's say something like 4 5 1 2, can it be pushed and made? It's again non-decreasing or decreasing, whatever be it, but it is not sorted. So 100 is not possible. If a number is not possible, you just have to ignore that number, that is 0. 0 means this number is not considered. That's all. If 4 comes here, 4 can be added because 4 is same, right? That's all. Now the answer is very simple. We got the logic. Only thing is we need to code this. That's all. Like there is nothing to think about it. We can straight away code it, but while coding it, we need to make sure we are implementing everything properly. So let's take the same example and try to code this in this way. So what do? 4 5 1 2 3. You don't have to optimally select these numbers and make it large. Whatever be the number comes, if it is beautiful, if it is there. Now, what are all the parameters we need first? First, we might need the deviation, right? Phi is greater than 1 means, so suppose there is one deviation that can happen, like this one deviation can happen. 4, 5, 6, 7 also can happen. 4, 5, 1, 2, 3, 4, something like that can also happen. For that, we need to have a control. So, what do I call? I call that control as flag. Initially, we can set it as 0, okay, it's false. Now, what is one more thing we need? We need to know the previous element's value. So, what do I call that? The previous element's value will be, I call it as last. Okay, last is the previous element's value. Now, let's say that we need to know the first element. Why do we know why do we want to know the first element is? It is because suppose 1 comes. Okay, 5 is less than 1, okay. But if suppose 100, as I told you earlier, if 100 comes, I need to check with the number 4, right? Because 4 is the one who is going to come after 100. So I need to keep track of this. So for that also, first, let's keep this as -1, like nothing is triggered first. Now, I will code along with this example, and let's cross check the solution first. Now, if only one number is there, what is our thing? If flag is 0, there is no deviation. So what do I do first? If first is equal to 1, first equal to -1 means there are no number that has been started. Definitely the number is beautiful, right? So what do? I keep the last means the previous number is also the number, that is 4. Let's assume this is all num, okay, these are all the variables, and first is also the same number. First is also same, last is also same, and if both are same, what do? I simply print it as 1. Okay, now this is the first condition. Flag is not there. I don't know what happened now. I don't know when will the flag come. We are not doing anything now. Now 5 came. When 5 comes, I need to check with my previous element. I need to check whether there is a deviation happened or not. There is no deviation. So first is definitely not the first element. 5 is not. So what do? Else if, what do I have to check? Whether the last element is less than or equal to number. If it is less than or equal to number, what do? Last becomes the number, right? Because 5 is greater than 4. 5 is greater than 4. 5 is greater than 4, or 4 is less than 5. Last becomes 5. This becomes 5, and this is also a possibility. You just print 1. Else, suppose let's say something like 1 comes. Maybe okay, 1 comes here. What should I do now? I don't know. So I just have to check like I have to check what do I have to check? Whether this one is less than the first number or not, right? So this is 1, right? This is num. So that is else if, let's say num is the 1 here and 4 here. 4 is what? 4 is the first number. First number should be greater than or equal to this. That is, a deviation is happening. I am just writing down the condition. So if that is happening, what do? I trigger the flag. I am telling the flag that, you know what, there is only one deviation that is allowed, and that deviation is here. So I just make flag as 1, and then you simply print 1. There is one more thing that you need to do. You have to make the last as the number. Last is the previous number that you are telling. Okay, that is clear. Suppose let's say number is something like 100. First is greater than or equal to 100. It won't work, right? So for that condition, we simply put else as 0. Okay, this is else as 0. Now everything is done. Flag, we marked it. Now next number comes 2. When 2 comes, I know that there is a deviation that already happened. So all these numbers, all these conditions come under a else block. This is under else block when flag is false. What happens when flag is true? When deviation comes, what are all the possibilities that can come? So what are the possibilities? Let's take the numbers exactly. So 1 should be less than or equal to 2. That is true. And 2 should be less than or equal to 4. As I told, 100 should not come. 2 is less than or equal to 4. What is this 2? This 2 is the number. This is also the number. What is 4 here? 4 is the first number. And what is 1 here? 1 is the last, that is the previous number. Now if these conditions are satisfied, what should I do? It is possible that the number exists. I print 1, then the last becomes the number, that is the previous one. If this condition is not satisfied, in any deviation I simply print cout 0. Now let's go for 3. If it is 3, I say that the deviation already exists. Now same thing happens here, 3, and number is also 3 here. And what is first? First is 4, last is 2. 2 is less than or equal to 3, 3 is less than or equal to 4, cout 1, last becomes 3. That's all. So what did we find out? We just took a random example, we took each of the number, we coded that. So once a deviation comes, we created a separate logic and coded this. That's all. So this is a much more cleaner way. What do we do? If it's the first number, the first and last number remain the same, answer is possible, so cout 1. And if the number is greater than or equal to last, it is just increasing before any deviation. I just make the last pointing to the next number, cout 1. And if there is a deviation, I need to check whether the first number is greater than the deviated number, that is 4 is greater than or equal to 1. Last you mark it as 1, flag as 1, telling there is a deviation, print 1. And in all other cases, if it is 100 or something, you just print 0 by default. Now after 4 5 1 2 3 we noticed, right? If 2 comes, what happens? If 2 comes, I understand that there is a deviation that happened. Then you put all the numbers, the previous number is the last. 2 should be greater than or equal to 1, and 2 should be less than or equal to the first number. Because why did we do that? 4 5 1 2 3. For 2, why did we check? Because 4 5 should come here, that's why we are noting down here. So 1 2 4 5 should come. This is just an example. If suppose 300 comes here, we'll mark it as 0. So we are just checking the real-time possibility. Then last, you put the index here and print 1. In all other cases it is 0. So that's all, guys. So what, it's very simple. Like we just directly took an example and implemented it, to be very honest. That's all. And this is the submission name. If you have any doubts, please let me know in the comments. Until then, see you in the next video.